When asked to solve equations simultaneously using an algebraic method, it first of all means that we can't go about drawing the two linear graphs and seeing where they connect. We have to do it algebraically. This means that we have to use a system of elimination and solving to find the values of x and y. So the first thing you're going to do is you want to make the coefficient, the number in front of x, exactly the same. So we have 8 and 12 currently. To do that, what you're going to do is you're going to multiply it by the other coefficient. So we're going to multiply the top one by 12 and we're going to multiply the bottom one by 8. That is going to give us two new equations to work with, which we are then going to label equation 1 and equation 2. So the first one would end up giving us 96x minus 72y is equal to 48, and we're going to label that equation 1. And the second one is going to give us 96x minus 80y is equal to 16, and we're going to label that equation 2. Labeling it equation 1 and 2 just gives us the opportunity to make our explanations a little bit shorter, so it's really clear what we're doing at each step. The next thing you want to do is eliminate the x variable. You want to get rid of x completely. To do this, considering we have 96 on both equations, we're just going to subtract 1 from the other. So we're going to take equation 1 and we're going to subtract equation 2. We're going to do that for everything that we have in a very similar way that you would in a column method. Be really careful that you are watching your signs as well. So 96x, take away 96x is going to give us 0x, or just nothing. So we're not going to bother writing anything down. The next part is the trickiest because we have some other signs to contend with. So what we're going to need to do is we're going to do minus 72y and we're taking away minus 80y. So what we need to remember is that when we have these two negatives, it actually gives us a positive, actually gives us an addition. So we're going to do minus 72y, add 80y. That is then going to give us 8y left. When we do minus 72, add 80y, it's going to give us a value of 8y, or you could do 80y, take away 72. We're going to get left with 8y. Remember, we've still got to do the same to the other side. So on the other side, we're going to do 48, take away 16. That is then going to give us 8y is equal to 32. Then we're just going to solve for y. So all we're going to do is divide both sides by 8. That's going to give us 1. So we're all just y on the left-hand side, and 32 divided by 8 is going to give us an answer of 4. So we now have a value for y. What we then need to do is find our value for x. I'm just going to draw a space here for us to do so. So we're going to substitute y equals 4 into, and then pick an equation. Always, as a rule, to make your life a little bit easier, always pick the first equation you are given. So we're going to substitute that into 8x minus 6y is equal to 4. And that's what we're going to substitute our value into. So substituting it in, we're going to get 8x, take away 6 times 4 is equal to 4. 8x minus 6 times 4 is 24, and that is equal to 4 then as well. What we're then going to do is ask ourselves, how can we go about solving for x? So what we're going to do is we're going to add 24 to both sides. That's going to give us a value of 8x is equal to 28. Then all you need to do is divide both sides by 8. That's going to give you a value of x is equal to, slightly trickier this one, this division, but not definitely something you can do without a calculator. 8 into 28. 8 into 2 doesn't go, so 8 into 28 we know goes 3 times, but you then have 4 left over because 3 times 8 is 24, but remember the 0 lives there as well, so how many 8s are in 40? That would be 5, so we're going to end up with x equals 3.5. You have then solved the simultaneous equation, because when we ask you to solve, we know that means find the values of the unknowns, of the variables, of the letters. So we have found that y is equal to 4 and x is equal to 3.5. And we are done.